Behold the dawn of an ancient future. The secret of this engineering will amaze you.
Before we break down the engineering behind these massive monuments, subscribe to the channel, leave a like, and drop a comment below. Travel back 25 centuries to the Marv-Dasht Plains. This photo shows the reality for a traveler: days of shimmering heat, dust-choked horizons, and jagged mountain crests. There is no natural feature here that suggests a city could exist. Then the horizon changes. Rising out of the living rock like a mountain forged by hand, the imperial citadel of Persepolis materializes. To the ancient Greeks and Babylonians, this was the terrestrial court of the King of Kings. The scale was so vertically ambitious and the stonework so flawless that rumors spread Darius the Great must have harnessed the power of giants to lift these monoliths. Modern engineering reveals a different story. The Achaemenid builders managed logistics and structural physics at a scale that forces us to reevaluate the technological limitations of the ancient world. We are investigating the specific mechanisms behind two engineering nightmares, geographical and astronomical challenges that would force a modern construction team to abandon the site. Darius demanded his ceremonial capital sit directly at the foot of Mount Rahmet. As you can see in this photo, that meant building on a chaotic, uneven slope of volcanic limestone in one of the most seismically active regions on Earth. Thousands of stonemasons spent years cutting away millions of tons of solid bedrock to create a level foundation. They filled natural chasms with 50-ton limestone blocks to raise a flat, artificial plateau spanning 135,000 square meters. Look closely at the retaining walls in this image. These stones rise 50 feet above the plain, yet there is zero mortar or cement binding them. The stability of the entire citadel relies solely on the precision of the joints. The Persians employed megalithic jigsaw masonry. Instead of uniform bricks, they carved irregular polygons that interlock with microscopic tolerances. This eliminated straight horizontal seams, which are the primary failure points in a standard wall. Should a massive earthquake hit, these blocks do not crack. Instead, they glide and vibrate against each other, behaving like a fluid wave of stone that absorbs kinetic energy before settling back into alignment. The architects used the weight of the mountain against itself, creating a foundation that has remained stable for over 25 centuries. With the earth conquered, the builders turned to the sky. The emperor required the architecture to synchronize with the cosmos to inaugurate Nowruz, the Persian New Year. Ambassadors entered the court through the Gate of All Nations. These 25-foot stone lamassu guarded the entrance, but the gate's primary function was actually astronomical. The structure is a precision instrument. The eastern and western portals align to a fraction of a degree with the celestial equator. On the morning of the spring equinox, as day and night reach equal length, the first ray of the rising sun penetrates directly through the center of this stone gateway. The ray of light strikes walls of highly polished limestone, scattering a liquid gold glow across the entire chamber. To the delegates standing in the dark, it appeared as though the sun was being birthed by the palace itself. The Achaemenid kings used this gateway to prove to the world that their empire was synchronized with the eternal rhythms of the solar system. These ancient builders mastered the tectonic forces of the earth and the alignment of the stars. The citadel stands as a terrestrial machine engineered to survive seismic shifts and environmental extremes. But the vertical challenges were even greater. This photo shows the Apadana Palace pillars, forests of limestone, so tall and thin they should not be able to stand under their own weight. Deep beneath these floors, an intricate subterranean labyrinth was designed to keep the structure dry during catastrophic floods. We also need to explore the mystery of the stone sentinels that survived the fire and wrath of a legendary conqueror. We will reveal those gravity-defying secrets in Part 2 of the Iron Titans. Mastering the flat Earth was only the first step. To project true imperial authority, the Achaemenid kings had to build upward. These Apadana pillars reach 65 feet into the air, the height of a modern 6-story building. To the ancient world, this was an astronomical feat, nearly twice the scale of the Greek Parthenon. Every column supported a massive wooden roof, crafted from Lebanese cedars, wrapped in gold leaf and draped in heavy tapestries. This created a precarious, top-heavy load. If the downward weight of that roof tilted by even half a degree, the resulting leverage would snap the 40-ton limestone pillars at their base and collapse the palace. The architects solved this by placing 30-ton stone capitals at the peak of each column. These were carved into twin animals, like these kneeling bulls. The flat, intertwined backs formed a saddle that held the wooden roof beams, centering the structural stress down the column's vertical axis. By perfectly aligning the weight, the builders forced gravity to act as a stabilizing glue, holding the vertical giants in place through its own downward pressure. Even a perfectly balanced column faces a violent threat on the Iranian plateau: constant earthquakes. These ruins have stood atop active fault lines for over 2,500 years. To survive, the columns were built as stacks of multiple drum-like cylinders rather than single, rigid blocks of stone. Inside the joints, architects carved dovetail grooves, inserted iron bars, and poured in molten lead. The cool bled created a flexible metal cushion. When a tremor strikes, the cylinders sway like palm trees, absorbing the shock and settling back into alignment without snapping. These Achaemenid builders had engineered a base isolation seismic system millennia before the invention of modern structural mechanics. Beneath these towering columns, the engineers had to address a separate, hidden danger. Every winter, millions of gallons of torrential flash floodwater crash down from the slopes of Mount Ramit, directly toward the palace terrace. If this water saturated the terrace, the soil would liquefy and shift. The massive foundations would sink, causing the 65-foot pillars above to instantly topple. To preserve the city in the sky, the engineers first had to master the environment beneath the earth. Before the palaces were even begun, a miles-long labyrinth of drainage canals was hollowed out directly into the mountain bedrock. These tunnels reach heights of 6.5 feet, an underground maze large enough for an entire army to march through in total darkness. Vertical stone gutters connect every courtyard and roof to this bedrock network, allowing the system to instantly swallow the winter floodwaters. The water is funneled through the retaining walls, where it was historically used to irrigate the agricultural valley below. This urban storm sewer was so precisely graded that it still functions perfectly during heavy downpours today, protecting the surviving ruins from being washed away. In 330 BC, the city faced a threat that engineering couldn't predict: the arrival of Alexander the Great. Alexander ordered the city torched. The cedar roofs collapsed in mountains of flame, while silver ornaments melted into liquid rivers flowing for the stone gutters. As the royal drapes turned to ash, the conquerors believed they had effectively erased the Persian capital from history. Human fire accomplished what earthquakes and floods could not, consuming the combustible heart of the empire. But when the smoke cleared, the stone skeleton of the city remained. The builders had used mirror-polished black limestone for the door frames and columns. These elements simply refused to burn. The fire created a strange historical paradox. Its extreme heat did not destroy the intricate stone reliefs. Instead, it baked the surrounding mud brick into a hard terracotta shell, shielding the stone and locking its sharp details into time for 2,500 years. Alexander's fire failed to break the vault. Instead, the heat accidentally sealed it. Persepolis stands today as a synthetic mountain where geology and structural physics merge into a stone canvas, an architectural footprint that remains completely unconquered.